Hello everyone, I'm Gopal and we're a group of three people with Joanne and Rohan, while my major is mechanical engineering and they both doing mechatronics engineering. Today I'm excited to present the combination of our Fetch Robot path following project, highlighting the journey, challenges and achievements. Let's talk about the scope of this project. The Fetch Robot path following project aims to develop an autonomous robot system capable of following a predefined path. This project leverages advanced control algorithm and computer vision techniques to enable the fetch robot to navigate through dynamic environments. The ability to follow a path has numerous applications in various fields such as logistics and automations, and of course, there is no any project without challenges. Today we embark on an exciting journey, developing an autonomous path-following system with the Fetch robot in Gazebo. This journey begins with the extraordinary Fetch robot equipped with a powerful RGBD sensor, which combines colors and depth data. This sensor serves as our gateway into the fascinating realm of pattern recognition. Our ultimate goal to teach our Fetch robot to recognize blue spheres, but we're not stopping at recognition. We want the robot to follow these patterns with precision while maintaining a safe distance from obstacles. Well, we kickstart by installing ROS and Ubuntu, laying the foundation for our project. With Gazebo and essential packages, we create a simulated environment for our Fetch robot. After that, our robot needs a virtual office environment mirroring real-world conditions. Then, we code development is the heart of our project, starting with the blue color detection using the RGBD camera. Next, we empower our robot to identify squares, a fundamental aspect of our path recognition. Learning robot control is a crucial step in our methodology, and then integration and testing bring all components together for a functional system. After doing all this, our system is running perfectly.
So some of the challenges that we faced were one was resources as to how to approach this assignment and how to begin with. Along with the help of ChatGPT, there were still so many inconsistencies that made us confused throughout our project. The second issue that we faced was file sharing. Since most of them were done through an Ubuntu platform, the only way the files could be shared is through UTS webmail and constantly signing through. There was no much easier way. If we had something to be shared from our normal desktop to Ubuntu, it would require us to transfer data through our mail to get it done. There was no quick process. Another challenge was the pattern recognition, for we were unsure if the blue square would be detected. Uh, then comes the blue square detection, that is ensuring consistent and accurate detection of blue squares under diverse conditions is vital for the robot's navigation. Another challenge we also faced was the sensor noise and calibration. So what we heard is, for what we have noticed is the sensor does make good amount of noise and does affect the robot during its calibration and recognition process. And the other one is path planning. Designing an efficient path planning algorithm that allows the robot to follow the recognized pattern while avoiding obstacles can be a challenging task. So here we have the flow chart. The initial step is to start the robot, initialize the RGB sensors, basically get the gazebo simulator running. Second is basically perception, that is to capture the color data and to process the color data through this with the support of the sensor. Third is the pattern recognition, that is whatever pattern that we have put out there, that is the blue spot that we are detecting right now has to be recognized using image processing or deep learning for pattern recognition. Step 4 is navigation, that is to determine the location of the blue square. Plan an approach on how to reach over there through the code that we have set up. Then next is the safety check, that is to make sure we are not passing through any of the environment. Step 6, that is the movement. That is the movement of the robot is precise and clean, and there's a continuous update to the robot's position. Step 7 is the repeat of step 2 to 6 until the blue square is reached. And after the square is reached, the robot maintains a 1 meter distance from the square, indicating that it has reached its outcome. Yeah, and step 10 is the end. So here we can see we have a small project demo. And in this, we can see that a 1 meter distance is maintained from the robot and the blue square. As an amount of torque is applied to the blue square, resulting for the blue square to move, the robot makes sure that it still maintains that distance and stays 1 meter from the blue square. By the completion of our project, we have finally attained the robot to maintain a 1 meter distance from the blue square. This this basically resulted in showing us that the sensor was working. The robot sensor, the code that we used for the robot sensor to sense the blue square worked well, as well as the integration with Gazebo, which is one of the main things that is a simulator, worked well for us, I think, and was able to provide the outcome that we were looking for. So, in conclusion, I feel like we have learned a lot about MATLAB and sensors and controls. We also learn how the Gazebo simulator or simulation is integrated with the Ubuntu as well as with the robot operating system and how it's all connected together, and as well as able to detect the blue square, which is one of the main key things that is this use of sensors has been a journey for us, as well as uh, as well as able to set up all the necessary requirements required to get this program run, as in all the team meetings and group discussions and constant support of ChatGPT. But at the end, we were able to come with the conclusion of able to scan the blue square and keep a 1 meter distance. Yep, this is our presentation. Thank you so much.